Okay, hi. It is Tuesday, September 24th, the year 2024. This is week 2 of ILM 220. I am Brother Stevick. I am here to teach you. I am alone today, which is fine. Well, I think that's Kaladin Stormblessed behind me. I'm not really sure. I don't think it's Dalinar. Might be Kaladin. On top of a tower. Interesting. Anyway, today we're going to talk about week 2. I'm going to go over the what the expectations are for week 2, what you need to do. I'm going to go over some initial code stuff with you, and I'm doing some experimenting with this particular session with AI. There is a bunch of things going on. I don't know if y'all looked at last week's recording. But when I posted it, I had the notes from the AI engine that took that while I was talking, and it's going to do it again today. But apparently, I've done it in where it's going to include screenshots and things like that. So it should be exciting. I'm not really sure how it's going to work. We're going to be playing with this through the course of the semester because I find it a pretty cool thing to play with. So let's go ahead and get started and go over what the requirements are for the week. Okay. Get this share to work. Okay, am I sharing? Put you over here. No, it doesn't want to unshare here. Okay. Okay. There we are. Okay. I'm missing now. Let me do this here. I was sharing before this all started, so let me just that's interesting. Okay, so I'm gonna share this. I'm gonna share this screen, and I'm gonna click that and click share. Okay. Oh, what is going on now? I am doing all sorts of weird things here. Okay. Sorry, with these AI controls on, things are getting a little weird here. So let me I'm not really sure what's going on here. Hang on a second. Okay. Okay, there we are. Let me go ahead and close this out. I think we're doing okay now. I am sharing, I am recording. Everything here is going well. It took a minute to get this done, but here we are. All right. So preparation and reading for this week. Oh, first of all, just so you see this, if anyone's watching this, I don't know if you are. I used to do this thing where I put a special word in the video, and you had to find the word to pass the test. I don't think I'm gonna do that this semester. I think that's a little too much, honestly. So we're not gonna do that. But I have put the the weekly Zoom in the calendar, and the link is right here to join. Should you want to join? But all is well. So okay. Preparation and reading. We're gonna talk about these. I'm gonna show you how these clauses work, the select clause, the from clause. This is the purpose of this week, to learn these clauses. And you'll hear me use the word clause a lot because SQL doesn't necessarily have commands, they've got clauses. The select clause, the from clause, the where clause, the group by clause, and the order clause. These are all clauses. The PowerPoint slides you need to review in lieu of reading the chapters in the book. You don't want to read the chapters in the book, you want to do this. A couple of videos here, relational model, this one here is a critical one, how to reverse engineer a website. I'm going to go over that towards the end of what I expect on that one. All these little video tutorials, just kind of watch them as you have the chance this week. Here's some more things on how to do coding. And then we're going to write all these codes together here in a second. Okay. So that's preparation and reading. Nothing else to do here other than just do that. Then you've got your exercises. This is the first week where you're going to be expected to write queries. So you're looking at, write a query, write a SQL statement that retrieves the actor ID, first name and last name for all actors, sort by last name and then by first name. We will be talking about that today on how to do that. So this is very, very simple stuff. Do not panic. It is muy easy. Then you got your quiz, like always, 2 attempts, keep the highest score. A number of you came to me last week and said, hey, these questions are wrong. Some of them were just trick questions. There are some trick questions in these quizzes. So be wary of them. They're there to make sure you're reading the questions. So be aware of them. The last one here is the reverse engineering of website. So ignore this 5 to 10 minute video thing. I don't want 5 to 10 minutes. All I want is like 2, maybe 3 minutes. So here's your case study. Oh, let me real quick. There was someone emailed me yesterday about the essay for last week. I'm gonna be honest, I'm not crazy about the first week essay because it's talking about the CLI, the command line interface. It's an interesting question because it wants your opinion and it says, which do you think is better, and tell us why it's the CLI. I don't like the CLI. I think the CLI is good for showing off. I think it's just not intuitive. It doesn't help. There are a lot of people who swear by it. I'm not one of them. So this week, next week's essay will be a little bit more intuitive and make more sense on how to write it. So don't worry, we're all figuring this out together. All right, well, you're figuring this out. I'm guiding you through it. All right. So when you do this reverse engineering, all I want, it's very simple. Record a video 2 to 3 minutes long that shows you, pull up a website, whatever website you want. Okay. Pull up a website and then tell me what the back end of it looks like. You don't have to be specific. You don't have to draw pictures. Just, hi, I'm Brother Stevic. I'm going to use coppermine.net. This is the Brandon Sanderson Wikipedia page. I want to talk about how I think this database is set up in the back. So this is a super complicated backend. This is a Wikipedia. There is definitely a database backend to this. I see right here, I've got book titles. So right off the bat, I'm pretty sure there's a book table somewhere. And that's gonna have like the title, probably the page count, the year of publication, maybe the cover artist. That my information might be there. I see over here to the side, I've got books, character, culture, events, and eras. These are probably all tables to themselves, magic, locations. I probably have a character table. I probably have a culture table, an events and eras table, things like that. I probably have a Cosmere table to talk about different parts of the Cosmere to link things in. So if I click on here, if I click on the Stormlight Archive, it brings me to here, and I have, this is probably a character table. I might have a table. These might all be tables, but these might all be characters. And then I have another table called, I've got the character table and I've got the role. So I've got the role of Spren, role of Night Radiant, role of Voidbringers, things along those lines. So I probably have a table for each of those. I probably have a table for magic, between the magic systems. These are probably rows in the table. We have Knights Radiant, all the other Radiant orders here. So you get the idea. I'm just kind of riffing, kind of like, snowballing ideas on how these tables are built, what's there. That's all I really need to see. I just need to see that you have a rough idea on how table structure works. What would be a table? What would be a column in that table? How the tables may or may not talk to each other. This is week 2, unless you take, even if you took intro to databases last semester or 2 semesters ago, this is not something that you're going to whip out an ERD and go boom, boom. look at me. So just don't stress it. And just keep it simple. Okay. So let's go on to the code that I'm talking about today. So over here, I've got my SQL Workbench open up. I've got my databases over here. I've got the Sakilla database. Y'all should have this by now. If not, please make sure to get it installed. This is hypercritical to get the work done. When I run my queries, if you run these queries yourself, it may not seem to run the return the same values because I've been messing with this database for about 5 years now, so it doesn't look like yours at all. So the data coming back will be different because you've got a fresh, pristine database, and I've got one that's been around the block a couple of times. So let's just talk about the structure of a SQL query. We have a bunch of clauses that we use. We need minimum 2 clauses to run our first query. We need the select clause and the from clause. The select clause tells us what we want to see. The from clause tells the database where to go get it from. So select tells the engine what to see. The from clause tells the engine where to get to. So here, select last name, comma, first name from customers. So if I run this and I look down here, I have last name, first name, and this is from the customer table, which is right here. Okay. And it's giving me the last name, first name. Move this out of the way here. We have 599 rows that are returned. So we can see how many rows were returned in that. We returned everything. There were no limitations. So we know there are 599 rows in that table. This is a very, very simple query. And this is the fundamentals. Now from this point on, for the next 9-10 weeks, we're going to take this query and just add stuff to it to make it do different stuff. So this is it's not quite similar. It's almost like Legos code. Like you can take different pieces and put it together and get it to do what you want. Also, let me forewarn you, a lot of times during these sessions where I'm giving you code, I'm going to show you things and tricks that aren't in your book. They're not in the course. I just like to make the code interesting, to do interesting things. So there are some things that are going to be questioned on and some that aren't. So here I'm doing something else again. I'm doing the same thing, select first name, last name from customer, and so I'm adding a couple things here. So first of all, I'm adding this concat command. Concat is a command that concatenates 2 text fields or multiple text fields. It does nothing with numbers. That's a different set of commands. So this is concatenation. Concatenation takes multiple text fields and combines them into one column. Here, I'm taking the last name column. I'm joining it with a single quote, a comma, and a single quote. So what this is, I'm just joining with a comma, and I'm joining to first name. So what the result is going to be last name, comma, first name. And so when I run this, and then I'm going to do order by customer. So what this is doing, it's ordering. Oh, I can't do that yet. So I'm not going to do the order by yet. Okay. So here I run this, and I've got Mary Smith, Patricia Johnson, blah 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 blah. So right, okay. So, but notice here the name of the column is concat last name, comma, first name. That is a horrible name for a column. Your customers are like, what does that mean? That doesn't make any sense. So we need to be able to assign a name to the column, and we use the as command, as command for that. So here I've got as customer. So I'm going to say, hey, select this column. This is my output I want to see. Call it customer and take it from the customer table. So when I run this, boom, here we go. I've got, let me pull this up a little higher. I've got the customer column. I've got all these names here, last name / first name, and it's beautiful. Hey, Mark, how you doing?
Well, it looks like my alarm on my phone didn't go off, so sorry for being late.
Oh, that's fine. That's fine. Hey, I'm glad someone's here. I'm not talking to myself anymore.
Are you
Oh, they're
going over
talking about,
to select statements, select where from the whole thing?
yep, we're doing the select statements today. We're having fun. So what I would do, what you missed that I said was when I do these, I add code that's not in the book
Sure.
because I like to make it interesting. So like concat isn't a command you're going to talk about for another 5 or 6 weeks.
Yeah.
So
Where you combine sentences together, like if you wanted to make an address.
text fields, yeah,
Yeah.
anything that's texts. So here I got concat first name, last name as customer, and here I use this as an alias because as I just shown, if I run this just as this, and I don't give it a name, it's going to call it by whatever the concatenation statement was,
Yes,
and that's
you did the as command, so it has a real name. Okay.
yep. It's alias. It's one of the version of aliasing that we do. Here I'm going to order it by the customer column. Now I'm ordering it by the alias name, which is completely viable because it knows what it's talking about here. And so there we go. I did the same thing. I got last name, first name. I'm doing it by the customer column, which is this big thing. And I now have one column that gives the customer's name as opposed to two. And that's kind of what we do here. When we're writing these queries, we're taking the data that's in the database and presenting it in a way that the customer is going to understand better, whatever works better for them. Because of the way the database is set up, we have multiple tables with data that we're joining together to spit out to give the customer what they want. And if they see everything in an individual column, it's going to get confusing to them. You want to do it in such a way that it's pleasing to their eye.
Yeah, readable for a human. Yep.
Yep, readable for him, exactly. So here we're going to do the same thing. We're just going to add another column. We're going to do select store ID, concatenation last name, first name as customer, and we're going to order by last name now, which is the same thing as adding by customer. Running that, and now we just added the store ID to it, and it's the same thing. All I did was instead of calling it running by customer, I did it by just the last name. I could do it by first name if I was feeling weird.
Yep.
And run it, and it'll be the same thing, but it'll just now be ordered by first name. Which
and it does ascending order by default. You have to put in descending if you want it to change the reverse, right?
Yep, man, you're like my Ed McMahon to my Johnny Carson. You're rocking this.
Well, I took the ITM 110 class
Oh, did
last
you?
semester, so this is thankfully this is review for me so far.
Sweet. Yeah. I will get later on, I will get pretty technical with the code and do some pretty when we get to joins, I get it a little crazy with what I do because joins are fun. I love writing SQL code. And I'll say this now, I'll say it a couple times during the course of this, whenever you're writing code for the class, like start asking yourself, what else can I write? Just write queries to see what you can do and how the data gets out and see how to pull it out with all the commands that we have.
So
Just
in your class, do you want us to write inner join, or can we just use join since it's implied that it's an inner?
that's a great question. So that's a week 4 question, but I'm gonna answer it now because it's a key. Whenever I write code and whenever I encourage people to write code, I want you to be as specific in that code as possible.
Okay.
Because odds are you're going to write code for the company and then you're going to get a better job somewhere else and move on. And someone's going to come back and go, what did this guy write? So what you want to do is you want to make sure whatever code you write, it doesn't have anything that has to be like figured out. So if you do join, like if you do just the join, in MySQL, it means one thing. In Microsoft SQL Server means something else. In Oracle, it means something else. So it's best to do inner join or full join or left join in there. So yeah, I do recommend putting inner join and fill it out. And when we talk about the insert statements, I recommend like writing everything out. And there's a cheat to that too. I can show you a cheat to make that life easier on that one.
Cool.
So yeah, so again, to what you said, by default, it's ascending. If I want to change it to descending, here I've got here store ID concatenation of last name, first name as customer from the customer table. I'm ordering by store ID and ordering by last name. Now I'm ordering by last name. Store ID is not going to, it's going to be store ID and then last name or last name descending. It's going to order by store ID first and last name second. So my store ID is going to be together and then my last name is going to be together. Okay. So it does it. And if I did this, I can do this as well and have different ascending and descending values depending on what I want to do. So you can get super granular when you're making these commands. Again here, and like I said, all this, we're just adding a little piece of code for the next 10 weeks, just adding a little piece of code to this one query. Same thing, selecting store ID, concatenation of first name, last name as customer from customer. And now I put the where clause in. Now this tells the query how to filter the data. I don't want to see everything. I just want to see the last name is Miller.
I watched your little video. So when the SQL Server actually processes our select statements, it does where first, and
it does from first,
and then where then select, right? Okay.
Yep, from where then select, and then order by. Yep. We're gonna try that in a second, but yeah. So it's interesting when it converts this into machine code. It doesn't do it in the order you wrote it. And I'll if you watch the video, it'll explain why, but I'll explain why in a minute here too. So here, from customer, we're going to filter by last name, where the last name is Miller. And I've only got one. So just it limits that to me. Now, I can do what's called a nested query. I'm selecting store ID, concatenating last name as customer, because I don't want to forget that. From customer, where last name, and now I've got this command not in. Whenever I'm dealing with where clause, I have a couple of different, I can use in, equal, and what equal means, it is an exact copy. Whatever is in that database is exactly what I see here, where it equals Miller. Okay, I have like, and this usually follows some sort of percent sign, which is a wildcard factor. So it show me something where something is like this. I have in, and this is when I give it a string of information saying, show me where stuff is in here. And then I've got my standard greater than, less than, I've got not equal to this way. I've got not equal to this way. I've got greater than less. I've got all the standard set functions from second grade sets. But in any of these, I can add the word not in front of. So that means not like, not in. So here I've got, show me where the last name is not in this result set. And what I'm doing is I'm pulling last name from the actor table where the last names are Miller and Smith. Now, there's a reason, and this is a very pedestrian way to show what we're doing here. So this query will run, it'll get the value of here, and this is what's going to happen. It's going to get those values. There's nothing in there. That's just fine. And then when I run this, it's going to get this set of data and then see where it's not in. And I do this, and it shows me everything because there's no Miller or Smith in the actors table. Okay. Now, why would I do it this way? If I write a query that looks like this, where last name equals Miller, that is a static return. That Miller can't change. It's always going to be Miller unless I go somewhere else. In here, because I'm using a subquery or a nested query, this value set can change based on what's in the other table. So, and we'll get into more on this like when we do nested queries later on, but this is to show you when you're doing your where clause, you can drop a select clause into there as a subquery or a nested query. Okay. Here we got the same thing. Select store ID, can get last name as customer. I keep forgetting that here. From customer, and now I'm just doing where last name's in Miller and Smith. Order by store name, last name, run it. There we go. Here I've got the like command. Select store ID, concatenation customer first name from customer, where last name like D. So what this means is it just shows me where the first letter is a D. And I run this, and it gives me everywhere last name starts with a D. I can change the position of that. I can put it in front. And now it shows me everything where last name ends in a D. I do that. and it shows me everything where it ends in a D. If I put it in both spots, it shows me, it says, show me any last name with a D anywhere in that last name. It could be the first, it could be the last, it could be whatever. And here, now I've got everything. There's a D there, there's a D there, there's a D there. It starts with D over here, ends with D over here. So it just does that. So that percent, that percentage sign is the wild card. We could do a couple things here too. We could do, let's see, show me where the first letter is an A. I don't care what the second letter is. Where the
that an
third level
typed?
That's an underscore. Where the second letter is a D. I don't care what the next letter is, and then whatever. Let's do A space D. Okay, whatever that's. So when I do it this way, when I do percent, it doesn't care what, just anything that exists after it. Here, when I use an underbar, show me something where it says it starts with an A, then there's something that follows it. The third letter is a D. There's something that follows it, and then whatever's left. I don't care. So when I run this, I get these three. Because the first letter is an A, the third letter is a D, and then I don't care what's after the rest. This is very granular and very static, but it can be done if you're looking for something very, very specific. But also I can put not in front of this, and now it shows me everything that's not that. So now I've got everything but those three. I can do multiple questions within a where clause. Here, I'm changing to my film table. I'm selecting the title and the description from the film table, where description is like anything that's got those four docu in it, or it has cow in it. So it has to either have these four letters or these three letters. Doesn't have to have both of them.
So when we use or and or likes, do you care if they put them in all caps?
When I'm doing this for reals, I always put my commands in all caps. But when I type this stuff out, I do it really fast.
Okay.
It doesn't really matter. The thing about when you use the GUI like this, it changes the color, so you know what the commands are. The reason why we used to do all caps back in the day of like Microsoft SQL Server 6 was because it didn't change colors. So we did the caps so we knew which the commands were. But because it changes color, it doesn't need to. I mix it up all the time. So you don't have to. So here with the or, the description has to have this or it has to this. So when I run this, bring my thing back up here. I have, get you out of my way here. I have 31 rows returned. Nope. Where am I here? Here. I have 167 rows returned. Docu, no cow. Docu, no cow. Cow, no docu. These are some. If you got a few minutes one day, read these descriptions because I would watch these movies. A beautiful tale of a dentist and a mad cow who must battle a moose in the Sahara Desert. I mean, how does that not a moneymaker? So I have the word or there, so it's docu or. Here I've got the word and. What this means is it must have both docu and cow in it for it to return. I have 167 rows. I'll turn on this one. When I do this one, it's going to be significantly less. It's going to be 93. Docu. Where's cow in here? Oh, not like cow and not like it. Let me get the change that there. Where it's like cow. There you are. Okay, 8 rows returned. Fanciful documentary of a mad cow and a womanizer must find a dentist in the Berlin. Documentary of mad cow and a pioneer. Mad cow. So these are all my documentaries about mad cows. So again, when I have my where clause, I can get very, very specific in what I'm looking for. And I've got the and or ors in there. Moving down. This is a question on your quiz, and don't ever use this. This is stupid. This is what it used to be. So here I've got select store ID, concat last name as customer, from customer where last name like D. We've done this before. And I've got the order by. So this is what we call the cardinalization of columns. So it says order by 1, 2. This is column 1. This is column 2.
I didn't know you can do that.
Yeah, you can. It's an old way of doing it. I don't recommend doing it unless you don't like the person who's following you and want to confuse them. But you can do it. I've known a lot of coders who do this longer than I have, and I don't think anyone's ever done it that way on purpose. I don't know why you would, especially if you got like 14 columns, we like order by 1, 6, 14, and 3. I think it's just unnecessarily cruel. Okay, so we've dealt all this time with these concatenations. And again, concatenation is taking multiple text values and putting them into one. When we deal with numerics, it's called aggregation. Aggregating is a key element to writing queries. And there is a specific trick that has to be done when you're aggregating things. So here I've got an aggregation. I've got select rating and then count with a star sign. So what this is going to do, it's going to tell me how many rows per rating. Okay.
Do you have to use distinct with that or no? Or
no, this is the command I have to do, group by.
Okay.
So, and this is something I want to say 1,000 times. Whenever you're using an aggregate function, you must use group by, because group by, it tells it how to group it.
And then having is how you do a where clause from a group by, right? Okay.
Yep. Oh, you remember your stuff, man. So yeah, so we're going to get to that a little bit later, but yeah, so group by. So here, if I have an aggregate, I must have a group by. Any column that is not an aggregate function must be in the group by. So here I've got rating, count, from film, group by rating, order by rating. And I go here, boom.
So wait, you said that, so any column that's not part of the aggregate function has to be in the group by.
Yep.
Okay, let me process that. I think I remember that. I think that was hard for me to learn last semester because I was trying to buy only one column and then I had multiple columns and it was driving me insane.
Yep. Yep. And it doesn't give you an error because if I take this group by out, let's see, if I take this group by and run it. Oh, it does error now. Okay, cool. It'll say aggregate query that group by. So that's it used to not error. The new version must do it. So here, okay, so anything that's an aggregate has to be in this group by. So count is an aggregate function. Average is an aggregate function. I'm going to get the rating and the average. Max, min, min, max. So here, there's the average of the length. So what's the average length of a rated movie? So a G-rated movie is average 111 minutes, P, G, 13, and R, NC. I don't think your guys' database have NC-17, and I think I added that for kicks. I was saying that when you run your queries, if you run any of these queries against your database, they're not going to return the same results because I've messed with mine for 5 years.
Sure.
Average, then I've got maximum and minimum. Here's my, give me a rating. The maximum replacement cost, the minimum replacement cost with my group by. Here we are, my maximum and minimum. Okay. So, and that's just, so, and what you had brought up earlier, Mark, let me bring up now. So it's important to understand how the engine processes these queries because it doesn't do it the way you think it would. Because you remember last week I said that the database cannot, the engine cannot do anything with data that is static. Any data that is on a hard drive is static. So if you're doing anything with the data in a query, it's got to pull it out into the RAM first. So what happens is in this query, the first part is run the from clause. So it goes and you say select from where. Okay, the query, the engine goes, okay, you want, let me bring all of the customer table into memory. So it pulls all the customer table into memory. And then it says, okay, I want to know where last name has this stuff in it. So then it eliminates everything that doesn't have that. Now, the reason why from where follows from is because your your where clause does not have to be in your select clause.
Hmm.
So if I did, let me look at my customer table here. Okay, let me just look here. Let me do click select star for my customer table so I can see what the data is in there, so I can write a query to make do what I'm thinking. Okay. Okay. So if I go, where's what I'm messing with here? Okay, let me do this. So I do where active equals 0. Okay. I don't have the active column in my select series. So because every time it goes through a clause, it culls the data to only what you asked for. If it ran the select first, it would get rid of the active column and it couldn't do the search from it first.
Okay.
So here it pulls the customer table. So, okay, only one where active is 0. So it goes to the active column and gets everything where it's 0 and gets rid of everything else. Drops it from memory. Then it just takes the columns that you want and puts that into memory, and then it orders it, and then you get your results. So there is a question on the quiz this week. From where select order by is how it runs. And then if you, it obviously it changes when you have aggregates in there and things change, but
do we
this,
get into limit in this class or not really?
no, you can limit, the limit just limits how many rows come back.
Yeah.
Generally speaking, unless you're doing writing a query that just samples the data, you don't really limit how much returns.
Okay.
Like I think I'll talk about this later, but I worked for a company called Property Insight, and what that company did was it was a title insurance company, did title research for title insurance companies. So all the counties from all the states would send their data in, and we could compile it into databases, and then people would do searches for title deeds, property deeds. So it was interesting because this is why I know all the counties in Arizona. As I watch election results come in, I know what Maricopa County is, and I know what all these other counties are because I've dealt with these. So I understand all that. But anyway, so we had all these different tables for the counties, and we had one giant table for the transactions. Whenever a customer did something, it was one giant table, which ended up having millions and millions of rows. It ended up being a 6.2 terabyte table.
Holy cow.
So whenever someone did a search off of that table, we would do a limit of 1,000 rows to make sure this is what they were looking for.
Make sure that server doesn't blow up.
Right, exactly. And that's what would happen if someone did it. You've got to, when you allow normal people to run queries against your database, you have to indemnify it from their inherent idiocy. Because I hate to put it that way, and it's not because they're dumb. It's just, well, maybe a little bit, but because they don't understand that if they write a big enough query, it's going to crash the engine. Because if I had a table that was 6.2 terabytes big, and I write a query that returns 80% of that table, that means it's trying to pull in, I don't know what 80% is, but 4 terabytes of data into the RAM. And if I don't have 4 terabytes of RAM, the entire computer is just going to die because it doesn't know what it's supposed to do anymore.
Would it try to use a swap file, or is that?
So SQL database engines will not use swap files.
Okay, I didn't know that.
It will try to. The OS will try to, but so it's a great question. No one's ever asked that before. So the way the database engine works, databases are almost operating systems. Okay. They're very close because they exist unto themselves. They're on a server that has an operating system, but they do everything themselves. They have their own memory partitioning, their own CPU partitioning. their own RAM, their own disk partitioning. It's all independent of what the OS does. So it's interesting. So when you look at, and I can't do it on my computer because I got other things. This is like, if you look on a server and you pull up, this, what is it? If you're just on Windows Server and you pull up Task Manager, right? And you look at what's running, you'll see that MySQL is using, do this by name so I can find it quickly, please. Thank you. MySQL is using, right now it's not using any RAM, right? Or it's using 101 megabytes of memory. Okay. That number will never go down on its own, because what happens is the SQL engine does a couple things. It says, I'm allowed to use this much RAM and this much processor. And it's generally not percentage of processor, it's how many processors you use. Because most servers have, like, I've got my servers at work have 32 processors per server. I got like 160 processors. So I will tell the SQL engine, you may use 3 processors, you may use 6 processors, and it will choose 6 of them and use them. And those are theirs, and they can't use it. And if anyone else tries to use it, there's a huge, massive error, and the world comes to a screeching halt. The same thing with RAM. I still, this right here, you can use 101 megabytes of RAM, and that's it. And you can't use any more. But it will never release any of that RAM. It will always hold it in place, because whenever a SQL engine or any kind of database engine takes a resource into itself, it doesn't let it go. And here's the trick. When you look at a resource manager on a server, and it shows you that you are at 90% saturation because your database engine is using 90% of the RAM, that doesn't mean 90% of the RAM is active.
It means it's allocated.
It means it's allocated. So you can't trust what you see in the task manager. You've got to go into the database engine and see how much RAM is actually being used in there. So there's some nuances to checking the monitoring of how these engines run. And that's why swap files get weird, because the database engine only sees the 90% that's allowed to see. It doesn't see anything out of there. So it can't use a swap file because SQL doesn't recognize a swap file.
Sure.
Here's an interesting side story that I liked. So Oracle, that uses Linux and Windows, and then Windows and all these other databases, these engines, when they allocated processor and when they allocated RAM use, they used the algorithms of the OS to allocate the resources from the CPU and RAM. So instead of having anything within itself to allocate, it would just piggyback off of how the OS did it. Okay. A dozen years ago, there was a virus called Meltdown that came out. And Meltdown was a pretty ingenious virus because it infected the processor. It went in through the BIOS and into the processor, and that's where the virus hid. And whenever something accessed the processor through the OS, that virus went into whatever did it. And because the databases, which were normally databases, 99% of the time are insulated from any kind of viral attacks, because you can't get into them, because they have different authentication protocols. They have different things because the different OS living in there. But because the SQL engines use the OS's protocols to access the processor, the virus got into the database for the first time. So Microsoft and Oracle and all these other companies scrambled to write protocols for the databases engines to allocate the processor directly through it and isolate it from the processes that the OS uses. Does that make sense?
Yep.
So it's really interesting because that one virus forced database engines to become even more OS-like. So now a database engine is completely isolated from the OS. in every possible way. And when it allocates something to itself, it does not release it back unless you force it to. And by force it, I mean change the setting and reboot the server. You can't just purge it out. So that's a very how databases work under the covers is, for me, extremely interesting. I like the mechanics of it. And probably around week 5 or 6, I'm going to talk about how data is actually stored on a drive, because that's incredibly interesting on how that works. Because we talk about that's how fragmentation happens. Huh?
Like
It's
the sectors and the fragments and
it's called extents and pages. But you've got the right idea. But it's the way it's stored and why you can only have X amount of data per row before there's a whole thing to it. I'm not. It's 10:22. It's like a 35-minute discussion.
all
But
right, we'll stop there.
It's incredibly interesting. Anyway, so yeah, so when we do our queries, we run this first, and then because it wants to get rid of the data that's in the RAM as quickly as possible, so it's only the stuff that you actually need. So it purges it out pretty quickly, and it pulls it back and forth very fast. And when you do joins, it gets to introduce that, but that's basically it does the from clause first. So here, when I've got a subquery, what happens is it runs this query first. So it does this from, this where, this select, and then sets that off to the side, then does this from, this where, and this select, and then this order by. So when you're dealing with joins, it pulls both tables into the same time and does the same kind of magic to it. So that's kind of your behind the scenes work on how this stuff works behind how the queries run. So this week's code is just this simple. It's select from. I think you have a select by, maybe an order by. You're not using group by this week. They talk about it coming up. It's not part of the exercises. I think your book, your slides will talk about having. We're not going to talk. That's not part of these exercises. That's much later on. And then it definitely is not going to talk about concat or any of the aggregates. So, any questions on that, Mark? Anything about just refresher, complete refresher?
Yeah. So far so good.
Yeah, it's gonna be, and I don't think the curriculum introduces anything super new. Did you do case statements in 110?
I don't believe so.
Okay, so when we get to case statements and views and stuff like that, it's gonna be a little more advanced. But for right now, for the next 3 or 4, if you've done joins already, for the next 3 or 4 weeks, it's gonna be review. But like I said, on these Tuesday nights, I do expound upon the code. I throw things out there that we would normally talk about.
Cool.
And by your coding examples go into week 12, but by week 9, I've covered all the code. And week 10 is only going to be going over anyone's final projects. So yeah, so that's that. So and I'll rehash, because the again the requirement of doing the reverse engineering a website. I said all you're really doing is you're pulling up a website, like I use the Coppermind here, and you just say, hi, I'm using Coppermind. There's probably a table called, and I just want you to go through like what the tables might be.
Oh, so you don't want us to actually build the ERD and?
Oh, heavenly no. Oh, heavenly days, no. Okay. No. I mean, you in 110 probably could take a pretty good swing at this, but if this is, and sometimes this is the first one people take.
Okay.
And something like this, I pull up this because I've been doing this a long time, so this I could probably break down. But if someone tried to do this and is new to it, they would just break down. I suggest really simple things. I think I said last week, like I would always say, don't use family search. And then 3 years ago, I had the lead database designer for family search on there. And I'm like, you're the only person I'm allowed to do that. You can do family search. And he actually pulled up the ERD and showed it, which is really cool. He wouldn't give me a copy of that because proprietary stuff, but what are you gonna do?
Yeah, I'm sure there's some IP there that you can't
Oh my
share.
gosh. I would never want to work for the church in the IT division, but I would love to like look at the databases once, just get my hands on the schema, maybe in the dev environment, and just like look at it and play with it and see what it is. Because it tracks everything.
Oh yeah.
It could tell you like the last time you went to the temple and whose name you did and like, all
I'm
that other
gonna say
stuff.
the amount of in the transaction log there, holy cow. That's probably petabytes of data or even yottabytes, who knows?
I know they have an Oracle backend. That much I know. But yeah, that it's probably, I mean, could you imagine their genealogy database? How big that's got to be? Because Ancest, all the other database, all the other ancestry sites use our databases,
Yeah.
and all the work they do on theirs also gets put into ours. So Ancestry, MyHeritage, 23andMe, all that stuff is in our database, and they can use our database for free to do their stuff. Which is why we get to use Ancestry and MyHeritage for free. So,
Very cool.
but yeah, I mean, data just drives the world. I've said a number of times, and I think it's safe enough to say now, when the towers went down on 9/11, the reason why the majority of the businesses went out of business and couldn't recover is because their databases were on site. And
Sure.
and their backups were on site. No one thought of this. Was before cloud backups. This was just like they were doing tape backups, but they would literally put it to tape and then hand it to the guy in the truck and send him on his way.
Yeah, Iron Mountain.
Yeah, so Iron Mountain and stuff, like, because Iron Mountain's been around forever. But yeah, the businesses that couldn't recover lost their databases, and I've seen companies lose their databases and like they'd have to fold
That's it.
because that's it. That there's nothing left. So, anywho, all right. If there's no other questions, sir, I will put a pin in tonight. I will go ahead and bundle this up, put it up on the Facebook on the Facebook page, on the Canvas page tomorrow with the notes from the AI. I was saying that I've turned all the AI features
Zoom.
of Zoom on, and apparently at some point in time it's going to start drawing diagrams based on what I say. So that should be interesting. So we'll see what happens.
Well, I
But
appreciate the insights. That's what makes to me the class more valuable than just what's on Canvas. So
yeah, and that's really why I do these Tuesday night sessions, because I think that meeting here and like you asking questions and leading, if you act like, I would never expect it to talk about how CPU is handled in here. But if the question is asked, I will answer it, and I will go down those tangents because I love how this thing works. So I
very
had
cool.
some very, very good instructors early on in my career. Um, just as a sidebar, like Twitter isn't what it used to be, and I don't recommend anyone go there anymore. It used to be a great, great place
Collaboration.
for the community. There is especially for Microsoft SQL Server, there was hashtag SQL help, hashtag SQL jobs, hashtag SQL, and hashtag Oracle help. And there were like Oracle gurus and SQL gurus who just sit there in their break time and answer questions. There are guys who I met at conferences who I would put a tweet out there and say, "Hey, I need help," and they would, like, these guys who charge like $500 an hour for consults would say, "Hey, send me a link and let me see what's going on," and they would give me free consults for 20-25 minutes.
Wow.
So there is a very, very vibrant database community out there. Unfortunately, X has become
Toxic.
that's being kind. I was on there the other day looking for something. I'm like, how does even people? You try to. One of my hobbies is to play with algorithms on social media to see if I can control them to do things. But the X algorithm, I don't even think there's an algorithm anymore. I think it's just show me every stupid thing that's here. Because I logged in the other day and I'm like, it showed me like the first 14 is like, I don't care about any of this. This makes no sense anymore. But anyway, I digress.
All right.
But there is a very, very healthy, it now kind of is in the Reddit area, very vibrant community of database help. So anything you need, you can always find out there and get help with it. But anyway, that's where I learned all this stuff. I would take these classes from people and they would like, There's a guy, I forget his name, but he actually wrote the code for half the SQL Server, and he would just talk about how he did it, which was awesome. So,
Pretty cool.
yeah.
Well,
All right.
Thanks for paying it forward.
No problem. Take care, guys. See you later. Bye. Is that recording? Oh no. Oh, there it is. Okay.